It's a question.
Well, and let's look into that, because what needs to happen is we've got, in order for the knot to form and not to, because the knot by itself will dissipate. This simple knot here, there's nothing to prevent it from redeploying back out. So once it's here, how do we keep it there? And how do we make that mass stable, that energy knot? And the way that this model shows is that we weave this knot. If you start with a woven knot like this, and then you condense that energy like this. Here's a more elaborate one. Now this is a single loop I'm working.
Is that a single loop?
This is a single loop,
okay,
but with a lot more twist in it. We get this form here. And if we look, we find out that now we're into the world of handedness. There's a right-handed and a left-handed spirals going on in here, and that this innocent little loop has in it, it turns out, when we condense it and separate out the twisting, we see that this is actually a right-handed and left-handed twist that by interweaving itself, somehow we've introduced handedness into this form, and we can condense it out, and we see that here's a loop running around one-handed, and this other loop is working the other way, and it's on this loop here. If you look at it closely and watch what happens, it flips at the center point here from one side to the other. Now, again, this simple loop here, we can return it back to this. But the way that this gets locked into position is the model is telling me it occurs in the third dimension. And what that means is 3 loops interacting will provide the mechanism. And so it's not only 3 loops, each loop is both handedness. So actually what you're dealing with is 3 right-handed and 3 left-handed loops. This is where all the quark stuff comes from. And
you make those jumps so easy.
I know, sorry. I wanted to, let's see here. All right, what this one is 2 loops. Instead of taking 1 loop and weaving it around, I took 2 loops and wove it together.
Single string?
No, this is 2 loops. This is the form that 2 loops takes when it's condensed.
I mean, single string.
We can't see how many knots.
Two strings.
2 like this.
So
there, and this is 2.
Like twin lead, like TV twin lead, and you twist it. Is that right?
No, it's a single. It's 2 strings.
Yeah, that's right.
It's
Twin
2
lead
loops.
is 2 wires, and you twist it. And I think it's what he's talking about.
No, it's 2 loops. That if you were to separate,
I didn't bring
you would find he had to put 2 ropes together, burn the ends together.
Can you hold those 2 up?
So they're, yes, that's what I said. Yeah.
Here's the way to tell. See where I welded that together?
Okay.
That's 1 loop.
Right.
Okay.
And down
See,
here
that's
is the
what I said.
weld on the second loop.
Okay.
But when I expand this out, it looks just like this one. Only difference is double loops are going to have an even number of nodes, and a single loop is going to be an odd number of nodes.
You know, that's fascinating.
It is, because it has huge ramifications.
Sounds like what Greg's talking about in the other room right now.
But do you have your 2 loops with 2
Oh yeah,
different
there's
colors?
some
You
toroids.
have 2 different colors?
I know, I should do that.
Yeah, please.
And if you look
I'll
at
do these models again to show that this loop here. But the thing that's so interesting, that just blows my mind, is that when you condense, I mean, here the one wave is indistinguishable from the other, but when you condense them out, the single loop and double loop. All of the energy, which is the twisting of the rope, the nodes that are produced on this, condense into just one. And depending on which one I grabbed, it's going to be right-handed or left-handed, this other loop. So here I've been able to take the combined energy of two loops and transfer it all to one. And now, again, there's nothing that prevents this from unfolding back to this form again, deploying itself, condensing and deploying.
Can you do three loops?
Hmm?
Can you do 3 loops?
Yeah, here's 3 right here. Yeah, this is what 3 loops look like on a single loop. I mean, 3 weavings with a single
So
loop.
that's stable?
No, this will expand again. You don't get the stability until you do the 3rd dimension. In other words, you interlock in this way.
Oh, that's
I
beautiful.
like that one.
See, the red string was wound around like this, the red stick, and I condensed it like this to this point here, so that I did this, okay? And there it is in there. If you just forget the others and look at the pink one, the red one, that's what you got. And this is a condensation from both sides. Instead of doing it all to one place, I did it this way. And that allows you to see that this connector, this one that just goes around, becomes these two here.
That arrangement in your hand, you call that 2 loops? The 2 loops?
No, this is 2 loops, right?
Because the one
This
is
is 2 loops.
more
2 strings.
plastic.
It's this one here.
It's better than string theory.
Okay, that's,
Yeah.
don't say that.
Well, string theory is not even
It's
theory.
easier.
Now, when you take
String
and
theory.
put 2 other loops, and you get 3 loops interacting, and take a look at the condensed form, we note that all of the energy is combined to this nuclear center of this 3-dimensional event,
Is that a tetrahedron?
a tetrahedron.
So you have 2 legs of each color?
Yes, there's 2 blues, 2
Okay.
greens, and 2 pinks.
Okay, so that makes six straight elements, right? Which is a tetrahedron.
6 edges.
Six
Yeah.
edges.
You
6
mean the
sides.
6 edges? Yeah,
for
right.
a-
4 vertexes. And now, if taking that, this is the same thing. Where is it?
That's on the table, isn't it?
Oh, yeah. Here we go. But there was a smaller one that.
No, but the bigger one is easier to see.
Oh, here it is. Here's the next model I made, because now I wanted to do something with these leftover lines running across here from this model. So in this case, I wrap them around the other ones instead of just going straight across. Use these to wrap around. So then I got this configuration. And what I see going on here, what I like is, again, you have one spiral, one-handedness inside and the opposite-handedness surrounding it. And so in this one, I just wrapped a lot more around it and further consolidated the thing. And what I'm seeing is that this is a model for how charges work in an atomic type structure, or even particle structure too, is that this form is now become extremely rigid, as you can see by all this wrapping around, all
You're
this.
calling it form or structure?
Well, right.
No, you're defining your terms.
You know.
Right.
I want you to be consistent.
This is a form, and I'm trying to explain